I've had a number of you ask me about question number 20 from lesson 4. So it says you're driving along the road at 22.2 meters per second when you see a moose 50 meters in front of you. Okay, I'm going to gulp. Here's the car. Here's the moose. I can't draw to save my life. I guess what I'm going to try to figure out is how far the car travels before coming to a stop. And if it's less than 50 meters, then the moose is safe. If it's more than 50 meters, then bye-bye moose. So I'm going to use that 50 not in my data, but as a check. Seems to me what's happening here is for the first part, before I hit the brakes, let's say I hit the brakes right about there, I'm coasting along. I haven't hit the brakes yet. And then this part, this is where I'm hitting the brakes. So I'm going to divide this up into while coasting and while braking. And what I'm going to figure out is how far I travel while coasting, how far I travel while braking, and then I'll add those two together, and if they're less than 50 meters, I'm good. I'm going to go through the question and I'm going to list data whether I think it's before I hit the brakes while coasting or after I hit the brakes. That 22.2, I'm pretty sure that's a VI right here. Reaction time, this is before I hit the brakes, so T is 0.4. I decelerate at negative 6.4, that's after I hit the brakes. And it does say the word stop, so I know VF is 0. A problem, I need 3 things to find the fourth, and in each of these columns, I only have 2 things. So if I'm coasting, then my acceleration is 0. That's the third thing. And so now I can use d equals VIT plus a half AT squared. Although since A is 0, this whole term is just going to vanish because a half times 0 times t squared is just 0. The distance I'm going to travel while coasting is going to be 22.2 times 0.4. I'm going to travel 22.2 times 0.4. I'm going to travel 8.88 meters before I hit the brakes. What about after I hit the brakes? Good question. I know the acceleration. I know V final. I also know V initial. Why? Well, because I'm coasting, I'm going 22.2 meters per second right here. I'm still going 22.2 meters per second here. I'm still going 22.2 meters per second here. In fact, right when I hit the brakes, I'm still going 22.2 meters per second. Now I have 3 things. I can find the fourth. I'm going to use VF squared equals VI squared plus 2AD. I'm going to go D braking is VF squared minus VI squared all over 2A. It's going to be 0 squared minus 22.2 squared all over 2 times negative 6.4. Is this a fraction? Is there more than one thing on the top? Brackets around the top. Is there more than one thing on the bottom? Yep, brackets around the bottom. And I get that after I hit the brakes, I travel for 38.5 meters. And now I can combine the total distance. The total distance is going to be 8.88 plus 38.5. That's my answer button. And I get 47.4 meters, which is less than 50, so the moose will be safe. Part B is going to be really, really similar to Part A, except in Part B, I think I make the road slipperier so you can't decelerate as fast. That number is going to be smaller. I think when you run the numbers for that, you're going to find it's more than 50 meters, and so we have unhappy moose. I'll let you try that one on your own. Hopefully that helped.